Alright, so I haven't posted for a while, and I haven't had a lot of time to make videos, but I gotta troubleshoot our power factor correction unit, do some basic testing. Thought you guys might find it interesting, so I'm gonna shut power off. That's power to the controller, and that's power to the power factor correction unit. Most of you guys probably don't know what this thing does. It's a medium-sized industrial facility. We've got a lot of induction motors. In induction motors, you got your voltage curve and your amperage curve should be right in line with it, right in phase. But if you have a lot of induction loads, you'll pull your voltage or your current out of phase with your voltage. One way with an inductive load in all these induction motors, and a capacitive load pulls it the other way. So as we turn on induction motors, more and more induction motors, we turn on more and more capacitors in this bank to make sure our voltage and our current stays in phase with each other, and that helps with our electrical bill. Right now I'm just letting the capacitors discharge inside this power bank. I'm going to pause the video here and then open this up. Alright, so they've been discharged for about a minute here. Gonna open this fucker up. Click. Alright. So up here we got live voltage coming into the cabinet. I can show you. So up here, I don't even have to, don't even have to touch it. That's 480 volts, 3-phase. Disconnect. Look at the size of these fucking buses. Holy, that's like 1/2-inch copper. And those are, I don't know what size wire gauge. It's fucking big. Like bigger than welding conductors. Anyways, we got these big buses. These are reactors to help with harmonics generated by our VFDs and other fast switching devices, so we don't backfeed any harmonics into the electrical grid. But here's what we're going to be testing today. These are a bunch of capacitor banks. We've been having some alarms on the controller. One of the alarms was a over temperature alarm, so I replaced the thermistor. It's kind of like a thermocouple. Haven't had any over temperature alarms. I checked the fans, replaced the filters, but we still have a power factor alarm going off, so I'm going to check the capacitance. These are 3-phase capacitors, and I think each one should be like 100 nanofarads. I'll have to double check my sheet, but I'll go ahead and get the camera set up and walk you through. Alright, so I already went through with my chicken stick, and I'm not getting nothing here, which is good, but I'm just going to flip this to volts AC and double check that these capacitors have discharged all the way. So we'll just go phase to phase on the capacitor. Should see, yeah, okay, millivolts, yeah, millivolts, we're good. Maybe check to ground, got like nothing, so we're safe. I'll go to it's diode capacitance, nanofarads, so we should be getting about 100. What does that say? Yeah, 150, 150. This is stabilizing very quickly as well, which is good. 150. I'll have to double check with the manual specs, but I'm pretty sure it was 100 for this is 17.5 kVAR rated bank. I think 200, and maybe it's just 200 amps fully loaded. So that's 300 nanofarads. Where's that micro? I don't remember. 300, 300, 300. That's good. This seems about right. 300, 300. Minty. These are all checking out good so far, and I'll go down. Oh, bring me way down. check these down here. This might be a little interesting. Sorry about the shadow. But we'll go. These fluke leads are nice, but they're a little long for this. That is 300 nanofarads. 300. Yeah, you get the idea. I could have checked these fuses as well. These are fuses for each of the capacitor setups. I'll just go to continuity. Just verify here. These should all be good. And that's all good. Then we got another set down here that I can check. And just kind of an FYI, let me take this off. So we walked through checking capacitance on each of the capacitors, checking fuses on each of the capacitor banks. The reactors, you can actually check reactors just like you check an inductive motor winding, where you go ground to the reactor with a megameter. And I think these are like 2.5 mega ohms or 2.5 million ohms per reactor phase to ground of resistance. So you could check them too, but we're not having issues with these at the moment as far as I can tell. So anyways, thought you guys might find that kind of interesting. Up here we got a this is a transformer for control voltage. A couple fuses coming in. Those are 2 amp fuses. We got a 7 amp fuse up here at the transformer. And you can see here 175 kVARs, 210 full load amps on these capacitors, which is fairly substantial. And you might be thinking, why would you want to put 200 amps of additional load on your building? Well, it actually does save us quite a bit of money. If we correct our power factor, that 200 amp load for an 8-hour day doesn't make much of a difference. I mean, some of our motors are pulling 250 amps all day long. So this 200 amp load, when it corrects for a power factor, makes our electrical bill cheaper from the power company. So kind of neat. Anyways, hope you guys enjoyed. A little quick video, but yeah, stay tuned for some more. I'll hopefully have some more time to film some additional stuff here. So, all right.